Hi everyone. Today we'll be talking about chapters 6.2 and 6.3. I combined those two because they are really small chapters and they're related to each other. And you already know these, you've already done these. So I'm combining these two and it won't take more than 10 minutes. So be prepared, take your textbook, note-taking notebook, everything ready. So let's start, okay? So, writing and solving proportions. Before we go into what are solving proportions, we need to know what a proportion is, right? So we learned about ratios in the previous chapter, okay? So it is the relationship between two numbers or two values written like a fraction or written like with an, form like this or written like this, right? So these are the three ways that a ratio could be written. Now, what is a proportion? So, for example, I say 1 pound of probably sugar is $20. It's not that expensive, but I'm just saying. So 1 pound of sugar is $20. So I write it like this. So I say for $20 I can get 1 pound of sugar. Okay, so you come and tell me I got 2 pounds of sugar for $40. Okay, so I'm saying I got 1 pound of sugar for $20 from Publix, and you would probably come and say to me I bought 2 pounds of sugar for $40. So we are trying to figure out, oh, is this expensive? Whose is expensive, or is it the same price? So how can we figure it out? We can see if they are proportional, okay? So if two ratios, this is 20 over 1, that is $20 for 1 pound of sugar, is equal to or is proportional to $40 over 2 pounds. Is it proportional? Let's see. We know about equivalent fractions, right? What are equivalent fractions? If I say 1 over 2, I can write an equivalent fraction for this. Say, I can multiply with any number on numerator and denominator and come up with an equivalent fraction, right? So this would be an equivalent fraction. So when you compare two ratios, we do the same thing. We find if one is an equivalent fraction to the other or equivalent ratio to the other, okay? So here, so 20 over 1, if I multiply this 2 by 2 on numerator and denominator, I would get 40 over 2, correct? 2 times 20 is 40, 2 times 1 is 2, right? So this is equivalent fraction, or in this case, it's not fraction, it's called equivalent ratios, right? So this equivalent ratios is called a proportion, okay? A proportion is nothing but two ratios that are equivalent, okay? When two ratios are equivalent, then that is called a proportion, alright? So now, in this chapter, we are actually going to solve for x, right? We've been doing that since start of the year. We've been trying to solve for x all the time. In this chapter, we are going to use proportions, in other words, equivalent ratios to find out x, okay, to solve for x. So let's see an example, okay? So you can turn to page number 275 if you want, but I'll give that example to you on your textbook, okay? So example 1 shows solve the proportion, and this is what they have given. Again, this is a proportion. They have already given you that this is a proportion. That means it is an equivalent ratio or equivalent fraction, right? They have already given that this is a proportion. So only if they give you that this is a proportion, you can solve this way, okay? And they're asking you to solve for x. So what do we know when they say this is a proportion? We know that this ratio is equivalent to this ratio. correct? Since they say this is a proportion and they say solve this proportion, that means we know these two ratios are equivalent. So when something is equivalent, what happens? When you multiply a certain number with this, you would get this denominator, correct? Yeah. So what can we multiply 6 with to get 18? 3, correct? So 3, that gives us 18. And we know the rule, right? Whenever you multiply anything in the denominator, you do the same on the numerator. So you multiply the numerator by 3 and you find the value of x. So what is the value of x? X is equal to 15. We got it, right? See, this is only because they say this is a proportion. If this wasn't a proportion, you wouldn't be able to do this, okay? So we can go through a couple more examples and solve equations using proportions, okay? Solve for x using proportions. Okay, let's see another example. So solve this proportion using equivalent ratios, okay? So it says, 5/6 is equivalent to x over 60. So they're saying this is an equivalent ratio, so solve it. So once they say equivalent, what does it mean? You can multiply some number with the numerator and denominator to get this, correct? So which number can be multiplied with this denominator to get this? 10, correct? So 10. And also, as always, whatever you do with the denominator, you do with the numerator. So this 6 times 10 gives you 60 and 5 times 10 gives you the x. So x is equal to 50, right? Alright, so that's our answer. Let's see one more example, alright? (11/9) is equal to y over 81. So they say solve this proportion using equivalent ratios or solve using equivalent ratios. Both are the same. If they say solve using proportion, that is the same as solve using equivalent ratios, because proportion is nothing but equivalent ratios, okay? That has to be in your mind all the time. Equivalent ratios is equal to proportion. Proportion is equivalent ratios, okay? Alright, so these are equivalent ratios, that's what they say, and we have to solve for y. So let's see. What can we multiply 9 with to get 81? 9 again, right? So 9 times 9 is equal to 81. So we do the same on the numerator. So that will give you the y. Y is equal to 99. So, hope you are clear on this. We do have a lot of word problems on this. So I would like to touch upon at least one word problem. I want you to go to which one is this? I'm sorry. Page number 278. And do page number 278 and try to do the question number 25. Question number 25. So I will guide you through this a little bit, and then I want you to bring me the answer, okay? So the question goes like this. At a store, 5 erasers cost $2.50. How many erasers can you buy for $7.50? So what do they say? 5 erasers cost you $2.50 equivalent to how many erasers can you buy for $7.50? Okay, so this would be your equivalent ratio. Okay, and I want you to figure out using equivalent fractions and find me the answer. Get me the answer in your note-taking notebook. Okay. All right. So this is one way of solving the proportions, solving x using proportions. Okay. So our next chapter, 6.3, gives us another way of solving for x, or solving the equation using proportions. Let's see how it is done. I'm sure you've heard of this or even done these in the previous classes. So solving proportions using cross products. 6.3, solving using cross products. So what is a cross product? So let's take an example of equivalent ratio or proportion. So this is an equivalent ratio, correct? It's a proportion. So what is a cross product? So when you multiply the numerator from one side to the denominator of the other side of the equation, that is called a cross product. So how do we do it? 2 times 6 is equivalent to 4 times 3. So this is how you do the cross product. And using this you can solve for x. Okay. So let's do the same example that we did before and see how we can solve for x using the cross product. So what was one of the examples that we discussed in the last section was 5 over 6 is equivalent to x over 60, I think. Yeah. So remember, we solved it using 6 times 10, so 5 times 10, 50, right? Now, shall we use the cross product and solve it? Okay, again, the cross product is the product between the numerator of one side of the equation with the, product of the numerator of one side of the equation to the denominator of the other side of the equation, right? So this would be 5 times 60 is equal to 6x, correct? So let's see this. So this is 300 is equal to 6x. And like usual, you know how to solve for x, right? You have to remove the coefficient, right? So since this is multiplication, you divide by 6 on both sides. And what did you get here? 50. So x is equal to 50. You got the same value, okay? So now you know 3 ways of solving for x. One is just removing everything that is attached to x, removing all the terms and coefficients. That is one way. The second way is using equivalent ratios. The third way is using the cross products. Alright? So let's do a couple more examples of how to solve with cross products. Alright, this is from page number 281, example 2. So they are saying the hair grows 0.7 centimeters every 2 weeks. Okay, 0.7 centimeters every 2 weeks. And they're asking you how many weeks would it take to grow 14 centimeters of hair. Okay, so they are saying how many weeks, this is our question mark, or this is our x. How many weeks would it take for you to grow 14 centimeters of hair? So we can solve this using other methods too, but here in this particular chapter we are going to solve it using the cross product. Again, the cross product you cross it and multiply, right? So that will be 0.7x is equal to 14 times 2. So what is it? 0.7x is equal to 28. And what do you have to do here? We did that in chapter 3, right? Since it's multiplication, you have to remove this coefficient. So you divide by 0.7 on both sides. And that would give us 40 weeks. Alright? Got that? Right? Yeah, 40 weeks. So this is one example from your book. So let's see if we can find something else. Alright. There is another example, the same from textbook, page number 283. And they're asking, what is the question? 283. Bear with me just a moment. Okay, the question is, so you can read the question along with me, or you can read it later. The question is, a store is selling powder drink mix. That's question number 32 on page 283. A store is selling powder drink mix in 2 different sizes. You can buy 10 ounces for $2.25, or you can buy 35 ounces for $7. The question is, are these 2 ratios equivalent? So is it profitable for me to buy, this are ounces, right? For 10 ounces or 35 ounces? Or is that going to be the same for me? Okay, that is the question. So how do we figure that out? Again, we can use the cross product. So when you use the cross product to determine if these 2 are equivalent, then your final answer should have the equal value. Okay, I'll tell you what I mean. Now, let's do the cross product. Okay, this is 7 times 10 and this is 35 times 2.25, correct? So this would be 70. Is this equivalent? We still don't know if it is equivalent. And I worked this out. This was 78.75. So this is not equivalent. So I can say these 2 ratios are not equivalent, right? So if I buy 10 ounce, then that is cheaper for me than buying this 35 ounce. Yeah? So you see that? So this is another way you could be asked questions in proportions or equivalent ratios to tell them if those 2 ratios are equivalent. Okay? The one is to solve for equivalent ratios, solve using equivalent ratios. The other is they'll ask you to check if what they have given is equivalent. Okay? So let's do another example where we check whether those 2 fractions are equivalent. Okay? So another thing is, so this is what they ask. Tell whether the ratio form a proportion. So what is a proportion? Proportion is equivalent ratio, right? So tell if these 2 ratios are proportional. So that is the question. So they say 12 over 30 and 18 over 45, right? So they are asking you, are these proportional? So that is the question. So apparently when you see here, it's tough to use the equivalent ratio method to do it, right? It's not very apparent just by looking at it. So we can use the cross product and determine if these 2 are equivalent. Okay, so we still don't know here, so don't put equal. So still there is a question if this is equivalent or not, but let's do the cross product and figure that out. Okay, 12 times 45 is equal to, is it equal to, I don't know, 30. Okay, so what is 12 times 45? So 12 times 5 is 16. So what is 18 times 30? 24, 2, 540. So it is equivalent. Okay. So I can say now that these two ratios are proportional. Okay. So this is another question you'll be asked. So let's do one more on this. Okay. So again, my question is, okay, so they're giving two proportions again and asking you to figure out if these two are proportional. So how do I do that? Again, I can use the cross product. Okay, 12 times 50, is it equivalent? We still don't know. 20 times 32. So what is this? 600, right? And what is this? 640. Okay, so these are not equivalent. Okay, so that is all in this chapter. Okay, so you use cross product to solve for the equation, and you also use cross product to find out if two different ratios are proportional. Okay, so that is all here. But let's do one more thing. Now, how many different methods do we know to solve for x? Okay, so let's see. That is page number 283. So they have a question 36. The question asks you, describe three ways you could solve the proportion. To solve the proportion 6 over 10 is equal to x over 40. So they've already given you that this is a proportion. That means these are equivalent ratios. Okay, so they have already given you that these are proportions. Okay, so what is the first method? Remember from chapter 1 how we remove anything that is attached to x, right? So since this is division, what do? We multiply with 40 on both sides, right? And this is 24, so this is x. So this is how we did in chapter 3, remember that? That is one way of solving. What is the second way of solving? Since they've already told that it is proportional, then you can use the equivalent ratios rules, right? So what can we multiply 10 with to get 40? 4. And we have to do the same on the numerator. So now x is equal to 24. This is the second method of doing. What's the third method? Third method is using cross products. Since this is proportional, again, only because it is proportional. If it is not proportional, you cannot do this, or you cannot do the cross products. Okay, remember that. So 6 over 10 is equal to x over 40. And using cross products, I say 6 times 40 is equal to 10x. Again, using our method of removing anything attached to the variable, you divide by 10 on both sides and you get x is equal to 24. Okay, so now you know 3 methods of solving for x, not 1 or 2, you know 3 methods. So I hope this is clear. Proportions, rates and ratios involve lots of word problems, and that is what I'll try to address when we meet in the classroom. But I will touch a little bit on what we talked about here. But if you have questions, ask me before the class, or even when we are going through it, don't hesitate. Okay, I hope you bring all the homework. We check it every day, and it has to be thorough, and it has to have every detail that I tell here. Okay, so I'll see you in the class. Thank you.